Hi, welcome everyone. My name is James Serra. I'm an architect at the New York City Microsoft Technology Center, focusing on data and AI. And today's presentation will be on Azure Synapse Analytics, a data lakehouse. So a quick background for me, I've been in this industry quite a long time, focused on Microsoft data platforms for many years. And in my current role at Microsoft, I spend a lot of time with customers who are interested in this new evolution of what previously was called SQL Data Warehouse, called Azure Synapse Analytics. And today I'm going to spend some time introducing you to this product. I'll talk a little bit about MPP, Massive Parallel Processing, of what this product is based on. And then I'm going to do a demo. So demo will last for about half the presentation. And then I will talk about some storage and performance optimizations in Synapse that lead to its great performance. When we think of big data, we think of a data lake that I'm going to land this data into some folder system on there. It's going to be non-relational or semi-structured data. I can use it to experiment. And usually when building a modern data warehouse, you also have a relational database. This is where you put your operational type of data, source systems that are relational get imported into here. Data lake usually gets imported into here. And the challenge has been these were two sort of separate universes. And the idea with Synapse is to try to merge these together. So take a data lake and a data warehouse and create this data lake house and make it very easy to go from data, whether it's sitting in the data lake or data sitting in a relational database, all using T-SQL, which is a big part of this. But you'll see the ease of use that's credited to this product through having the data lake and a relational database so tied together. If we look at the modern data warehouse traditionally, it's been with a number of products and usually broken out into these stages where you ingest the data, store it, prepare the data, transform it, serve the data or model the data, and then visualize it using a reporting tool on there. And the challenge with this was there's a lot of different products that's jumping around. It's causes a little bit of confusion in there. The products maybe not integrated so well. Well, Synapse is fixing this by having everything under one single pane of glass and making much better integration with the products and also adding new features that I'll talk about in demo today. To clear up a little bit of the confusion, the product right now under GA was previously called SQL Data Warehouse. So this product, you can go and to the Azure portal, and if you type in Synapse Analytics, you'll see this product, and that's the GA version. And public preview is another version of that product that gives you a bunch of additional features. So while the GA version is continuing to get new features that are getting plugged into it, those features are also getting put into the public preview, but we're also having an additional number of features, and this is the focus of today. So we got the GA version and the public preview version, and the public preview version is what I'll be demoing today. I put this slide together to help you understand at a high level the features that are new combined with the features that are existing. And if we look at the top level here, you're going to ingest data using Azure Data Factory pipelines and data flows. Now, we don't call inside the Synapse, we don't call them Azure Data Factory, but we call them pipelines and data flows, but it's the same code base. So you're going to use this tool. You can use others outside of the product still to ingest data, but within the product, we make it much easier by ingesting data into various storage mechanisms here. And you'll see we have the relational database. So your traditional data warehouse on there, we call this a SQL pool. And that's what's the compute part of that. That SQL pool is attached to this relational database. It's a 101 attachment on there. So whenever you create a SQL pool, you'll create a relational database. You also have integrated into Synapse is the data lake store. And we use Gen 2, and this is your data lake, and that could be accessed also with provision pools through T-SQL's internal tables, just like you can before. And of course, T-SQL is used for the relational database. The new part is SQL on demand. So this feature is a pay-per-query and allows you to use T-SQL over the data lake. And this is a big change to before, where you'd have to go and say open up a Databricks notebook, create a cluster first, then you use something like Spark SQL after you attach the data lake to query the data on there. We've made it really easy, and you'll see that in the demo, to use regular T-SQL over files sitting in a data lake. We also have Apache Spark. So this is open source Spark. This is new. This allows you to create Spark tables within Synapse, and those Spark tables can be queried through Apache Spark Notebook, as well as the on-demand pools can use T-SQL to access the data in the Spark tables. And finally, we have Cosmos DB. We have a Synapse link that you can use from your on-demand pool to query the data in Cosmos DB that you may want to pull in and use that for reporting and querying. We also have Power BI integrated within the product for your visualization. And this allows you to easily use that product to quickly generate reports and dashboards off data sitting in any of these particular storage systems. Underlying all this is Azure Synapse Studio. This is the single pane of glass. This is new. And this is what allows you to use all these products and features without ever leaving the web browser tab. And the big change here is with the SQL on-demand pools. This gives you an ability to have a lot of different ways of accessing data and saving costs. So if we look at what the new modern data warehouse could look like, is each of these steps now has multiple options on there for exploring and preparing, which could just be transforming all files from, say, CSV and JSON into Parquet. Well, I can use the serverless version, I can use pipelines, I can use Synapse Spark. I can transform using all those, as well as the provisioned Synapse SQL on there. And then model and serve, I have a couple options on here, all based on Data Lake Store Gen 2. So some of the features of serverless here, think of it as I can use Power BI and on an on-demand pool to quickly query data sitting in a data lake. And it's going to be cheap because it's only pay for a query. It requires no setup time. And it's very easy to use because it's using T-SQL, which Power BI can therefore use it. So this gives you some different scenarios. And this is where I'm having a lot of discussion with customers on those scenarios, the trade-offs of all of them, the cost differences, the performance differences, and such. So you can think of now with the serverless, I can use it for basic data exploration. People could be dumping files into my data lake, and I want to go and see what those are, what's inside of these files. You'll see in the demo, it's very easy to right-click to see the contents of those files. So it's great for data exploration, and it can automatically infer the schema based on what's underneath the file. So if it's Parquet or CSV with header files, it automatically pulled it out. You can create a logical data warehouse. It's a virtual layer on top of the data, so you don't always have to move it into one central relational database. I can query this data as it sits in the data lake. And then data transformation. Because I can use regular T-SQL and I can use on-demand, I can use the T-SQL to transform the data, to convert it, to complete it, to these kind of things now. So if you prefer that method for interacting with data, it makes it very easy to do that. And we have a number of options now. If we look here, we have provisioned, on-demand, and Spark. So these are the three ways of compute. Each of these can access these four storage mechanisms. And I put in here the options available now because some are not here yet and will be at GA or soon thereafter. And then some of them have a little things to be aware of that I'll talk through the demo. And also note that the SQL pools when you're querying, can query these three different file types right now: Parquet, CSV, and JSON. The Spark inside of there can query any data in any format on there, but for the SQL pool, it's limited to those three. And I wanted to give you a quick introduction on MPP technology, which is the basis of how Synapse is built. If we look at traditionally, we have SMP, that's your SQL Server, and it's a scale-up technology where massive parallel processing is scale-out architecture. The ability to add additional compute and additional storage without having to go through a big hassle that you would have on SMP, as well as not have any limits, because I can continuously scale this out, where SMP, as you scale up, you're going to reach some limit on there. So that's the main difference between the two. And if we look at it from an architecture point of view, you can have this control node that's sort of the brains behind Synapse on there. Queries will be sent to that, and we have behind the scenes compute nodes, and each of those compute nodes has various storage on there, and those will run subsets of the queries on there. So if we look how that works, if an end user submits a query to a control node, that control node will create a query plan, but also parallelize the queries and send them out to the various compute nodes. They will run those queries locally, return the results back to the control node, so a subset of that data, because if the query has a whereas clause, mash it up, and then send it back out to the end user. And the end user is unaware of all this complexity that's behind the scenes on there. They just know about the control node. They think it's a regular SQL Server, but behind the scenes it's having these various compute nodes that you can continue to scale out to get extra performance, because you're distributing more of the queries among multiple nodes, which have multiple storage devices that they have pieces of the data. And so the way that works is, think of a star schema. And what you'll do is replicate these smaller tables to each of these storage devices. Because the tables are smaller, storage is relatively inexpensive. And for performance reasons, I'm going to replicate those smaller tables. However, a fact table, if we're using a star schema, will distribute that data among all the various storage devices. So they'll have pieces of data scattered across that. And this allows you to do the join locally without having to shuffle the data, which can be expensive operations, because the fact tables join in dimension tables, and those copies of dimension tables are all locally there. I can just do that join without having to pull it from other storage areas. When you set up your table, it's the one difference is you're going to have a distribution, whether it's going to be a hash key that determines how the data is distributed, or it's going to be replicated. But everything else then happens just like a create table when you're coding this on there. Behind the scenes, the create table will send smaller commands of create tables to each of the compute nodes. And then you can continue to use features such as partitioning to get even faster performance. But it's very easy for somebody who's a DBA or developer to go and use an MPP technology with minimal training on there. The big part being understanding how distribution works. And you'll have the concept of data warehouse units in Synapse, and it's a sliding scale, very easy to use. And the more you scale it, the more CPU, RAM, and IO you get on there. And so we have different tiers that you can select, and you can scale this up manually during the day, and it just takes a few minutes, usually under a minute, to complete the scaling on there. And so how this works is, if I start out with the lowest architecture, DW100, you're essentially getting one VM, one compute machine for 60 distributions of storage, with those are fixed to 60. As you scale it up, you will get more and more workers. So if I scaled up to, say, 600, you're getting one worker per 10 distributions. And if I go all the way up, you're getting 60 workers for the 60 distributions. So that's how its ability to scale out and get you to the higher performance. All right, so let's jump to a demo. So what you'll do when you log into the Azure portal is, as I showed before, you'll go to the workspaces preview, as we have here. You can see I've set up workspaces. Generally, you segment these out, different workspaces, by project. And underneath each workspace, if I click on that, you will see the ability to set up SQL pools. So this is the biggest thing you're going to focus on underneath each workspace is initially setting up these pools. If we go to the SQL pool, you'll see it's much like we currently have under the SQL data warehouse previously called. And the performance level I can scale up and down, and I can create a pool, SQL pool, which will be attached to a SQL database. I also can create Apache Spark pools. For those familiar with Databricks, it looks very similar in the configuration on here, where I have particular node size that I can choose. Right now there's 3 of them. I can auto scale this and specify the min and max that can be scaled up. So how much do I want to spend on that? So trade offers cost for performance on there. We also have under additional settings, auto pause, which you can enable, and you choose the number of minutes that you want before it shuts down, with the trade-off of once it shuts down, it takes a couple of minutes, 4 or 5 minutes to start back up again. So you want to balance that. I can create numerous pools. So here I created 4 of them, and I can separate them up, say small, medium, or large, and give certain people access to certain pools. And that could be a way to make some more high priority notebooks run for certain people. And it's a way to also maybe control the spending on that. And the SQL pools, you'll see by default, there is an on-demand, and then various pools I can build, each of them having their own database. So if we go back to the overview, you also see an important thing here is these endpoints. And this allows me to choose to use these endpoints if I would like to use this product or the databases inside of another tool besides Synapse Studio, which I'm going to demo. So if I wanted to go to SSMS, I can do that too by connecting to that endpoint. Once I finish setting up the pools, I'm going to click on this Launch Synapse Studio. And what those will do is go into Synapse Studio, and this is where I start. And as you'll notice as I go through this, I'm never leaving this workspace. I'm doing everything underneath it. And if I look at the starting point for most customers, it would be ingest. And for those familiar with Data Factory, this is going to look like the copy data wizard on here, where I go in here and I choose the source system, a connection I've already created, or I create a new connection. I can go and choose a number of different sources on here, and then I would choose the destination connection information, and then right away I have a pipeline that I can run once or on schedule to pull data from a source system into the data lake. So that's one way of starting, and what you'll have once you do that is a pipeline. So this is an Azure Data Factory pipeline, and I could create something like this copy data statement if I use that wizard. You could go and do it directly within here, but it's a shortcut process is that. And what you'll see is under everything I put into that wizard will be now here in this source and sync and other properties that I've set up on here. In addition to copy data, there's a lot of functions you have underneath here. I can call other products in here. I can call Databricks notebooks. I can call Azure functions. And typically customers are going to copy that data from something like SAP HANA into a data lake, and then they want to clean it. And to do that, we have this mapping data flow. And this is same thing that's in Data Factory mapping data flow, where I can take data, in this case, from a file that was copied in the data lake, and then I can visually create or use tasks to do things with data, such as join columns, clean the data by replacing data in certain cells. I could aggregate the data, and it's very powerful what you can do in the mapping data flows. If I were to look at one of these features here, such as the last 5 years of data, if I click on one of the properties, it takes me to a visual builder, and this is where I can use a telesense and such and easily populate the values needed for certain functions in there. So we've made it very easy to use mapping data flows for that transforming of data. And I can click on here to add other options. So this is very powerful and very easy to use. And a lot of customers are using this as the interface for that data transformations. What you'll do to populate a data lake is create a Data Lake Store Gen 2 account outside of this product. And once you do that, I can go into manage and I can link to this storage. So if I go to link services here, you'll see I've linked to a couple of Data Lake Store products or storage accounts here. And once I link to them, when I go back to data tab and I click on linked, you will see these storage accounts in there that I've the link to. Now this is where it gets really powerful with Synapse, is that I can go to Twitter data and think of how difficult it would have been beforehand to query a Parquet file. I may have had to go into Databricks, create a cluster, fire up a notebook, Spark notebook, link to the storage, which could be a challenge, and then run Spark SQL on it. Now I can go to this Parquet file, right click it, I can go new SQL script and select top 100 rows, and I run this. Now the magic of what allows me to pull the data in just a few seconds is this open row set, where you can see I've specified where this file is. It did that automatically, sitting out there. And once I run it, it looks at the Parquet file, pulls the metadata it found, and creates the columns for me. So I have results. I can go in here and use a chart function to quickly get some visuals of what this data is. So this is where it's great for data exploration. I could also have come in here, instead of specifying a file, I could have used such as a character like this and say, give me all the Parquet files on there, and it'll do such on there. So very flexible. You'll see it's using the connect on demand right here, and that's it. Right click it, boom, I have results. That's what's in that file. So I can do this against Parquet. I can also do it against CSV files. So if I come in here to look at a CSV file, we also have a way of called preview. Now, eventually, preview and select top 1000 will be on all the file types. For now, there's some that don't have it, but the preview, but CSV does. So I can click on that and right away, boom, it pops up what's inside that CSV file in there. I can also go into, say, the Parquet, and I'll right click that. And instead of using SQL, I want to create a new notebook. So if I go in here, you'll see I have to choose a pool. So I can choose one of these that I've created previously and run it. And now it's going to use the default of Python, and it's going to populate with the file information of Parquet, and then it's going to run Spark. Now, this will take a little longer because I haven't warmed it up. So it'll result in having the output here, and then after 15 minutes, it'll time out. If I do things before that, it'll be rather quick on there. So from here, I can just build out a notebook on here. So a lot of the work that went into even getting to this point of loading it into a data frame is now made a lot easier. Now, we also have the workspace, and this is where the databases are, the data warehouses I've created. So before, I created a SQL pool, and that had a database, which I also called SQL pool attached to it, and inside of that, I can open this up and see tables. So I can use this just like SSMS is, where I can right-click it, I can do new SQL script, and I can pull it up very quickly on here. There also is under develop is I can save scripts. So not yet script notebooks, but rather I can think of it as .SQL files and keep that within this workspace on here. And whenever I go and create a new one, I can publish it out to this workspace and make it permanent, or I can just discard it if I don't need it again. But I can come here and do things like, well, let me query on here. In this case, the sales table has almost 30 billion rows on there. So if I go and run this query, this is where it's going to use the MPP technology. And I'm going to query 30 billion rows, and it took 2 seconds. And it joined, looks like 5 or 6 tables here. So this is the power of this. Now, there could be results in cache, and it could take longer if it's not in cache. There's also result set caching, which I'll talk about later, but I don't have that result set caching on here. And so you can see how quickly this runs. And this is based on the scale set, which I push up to 3,000. So it's very fast. If I go down to 100 or so, it may take 10 or 12 seconds. But even that is incredibly fast compared to using a regular SQL Server and an SMP technology. Okay, so moving on, I can then go and look at another feature that we have in here is copy into. So we've made it a lot easier to copy data that could be sitting in a data lake and say Parquet file. And this copy into, in this example, I created a Twitter account, a Twitter table in here, and I'm going to use a copy into to pull the data from this data lake file, this Parquet file, into the Twitter table. I won't run this now, but this shows you how easy this is to do. And this copy table is extremely fast. You can pull in billions of rows very quickly on there. So it's a new, easier, and more performant way to copy data in here if you choose to use this. Now you can use Data Factory like I showed before, but there are some performance benefits of using the copy into statement, which you can just call from Data Factory if you want. So definitely you want to check that out. If we go to the Orchestrate tab here, this is where we can see those pipelines that I had before on here. And one that I wanted to show is the SalesDB migration, where you can see in here, I'm sorry, the MarketDB migration, you can see in here, I can also call a notebook that's sitting in Synapse on here. And that is under settings, where you can see this is a notebook I chose. And so I can run that notebook within here. If I go back to develop under here, you'll see this is where I have the Spark notebooks that I've created. As an example, I can have this product recommendations notebook, and I can choose the various different languages from Spark to use. So we have 4 currently. And then I can go and build out this notebook. I can call libraries on here. In this case, I'm using that command that I had before where I'm loading data from a file, a CSV file in this case, into a data frame. And then I'm going to train that model and then run that model and output the results into the data lake on there. So a quick example of what a notebook could look like. So if you need to use Spark, boom, it's built in. I'm never leaving the environment in there. And because of the shortcuts of right-clicking things, it's very easy to start pulling in data. The other thing you're likely going to do is want to use Power BI. So underneath this Orchestrate or this Manage tab, this is where I can define the Power BI workspace I want to use. So you'll create the Power BI workspace outside of this environment, and it's linked to it. And just like it is to data lake stores. So if either of those products, things are done outside of it, it'll show up in here. So if Power BI created the workspace, I created the report. When I link to it, it'll show up in here. And then if I create reports or modify reports in either one, it'll show up in the other one in there. So if I now go into the Develop tab here, you'll see I have Power BI that I've linked to, this workspace here. I have the Power BI data sets that'll show up in here. And if I want to create a new one, they have a shortcut process where I can choose the SQL pool I want to use and download the pbids file, which is the connection information. So I can then quickly use Power BI Desktop if I wanted to interface with the data that's sitting in the workspace here and create reports. Or I can just come right here and create reports this way, or modify reports that were previously created. So you'll see in here, and a report I created previously using a decomposition tree. This is using the data from my SQL pool on here. So I can just come in here and visually create the report and build new ones on here. I can even go into Q&A, and I can come in here and decide to ask some questions on the data. That's made a lot easier with this Q&A feature that was added to Power BI not that long ago. So I can say profit, say by country, and as I'm typing it in, it's pulling up the data, and I can say I want it by product category, and then as a, say, a tree map, and it pulls that all up in there. And this is against some of these tables, which could be billions of rows in there. So it's very, very performant. Also on here, we have under the data tab here, we have all those databases, and you'll notice the Spark. So as I create Spark tables, they will show up in here and be able to consume them via on-demand SQL. So this is real interesting. If you create Spark tables, and the one limitation now is it has to be Parquet, I can start using a Spark notebook. I can access that Spark table that I created. Now, behind the scenes, when I create that Spark table, it will copy the metadata of the Spark table over into the SQL on-demand database, which is not really it doesn't have data in the database, it's just metadata. And it will have that metadata that goes to the Spark table. So I can then shut down that Spark cluster but still be able to access the data in the Spark table. So that's a really cool feature for cost savings and also for ease of use to use T-SQL now against that data that was created with the Spark table. All right, so I covered most of what's the high-level features on here. Also to be aware of, there's a monitor tab. So you'll see this looks a lot like what you've seen in a Data Factory when I want to go and visualize the runs that were created previously. So if I look at this of previous runs I have, I can go and drill down into this. I can go and click on the glasses there, and I can see the details of when this pipeline was run and the data that was copied over on here. So I also can see when I ran Spark, what that looked like, and a SQL request I can pull out of here, and you'll get some information on that, so you can see what people are doing against the workspace on there. So that's just touching this. There's a lot more features that are in this product, but because of time, I'm only showing you a handful of them. Great. So now let's go and dig a little bit more into some of these features of this product. So if I go back to my deck here, there's some key features that are in this product that you won't find elsewhere. We have some traditional features that you will find elsewhere, like clustered comps or indexes, and there's a lot of different types of indexes you can use if you need additional performance. You still need somebody to go and check out these query plans that may run slow, understand how MPP technology works, and then tune things. You also have the ability to distribute the data in, I mentioned hash and replicated is also a round robin. So some of these will be better depending on your situation. So you want to learn these to make sure you get that performance. On there, you can use partitions as a further enhancement for performance. And a little more details on distribution methods that you'd want to use based on what you're trying to do. For example, a staging table, recommend using a round robin method for that, and that will make it faster on there. When we look at database views, I'm sure you're familiar with typical views. Well, they have one thing that goes farther. It's materialized views, which are even better than index views. And these allow you to take data that's sitting in a relational database in the SQL pool, have billions of rows in there, and you want to improve the performance. Well, what I can do is take that table and join it, and as well as joins with other tables in there, and create a materialized view on top of that. So where it adds value compared to a regular view is it copies that data, aggregates it. You have to have some kind of aggregation clause in that view, and it will put it into another table and automatically sync changes that happen to the base tables with the aggregated results in the material view. And even better, I don't have to specify when I'm writing a query that I want to use the materialized view. It will automatically use that. The advisor will pick it out. So imagine I submit a query against a table that's a billion rows and it's joining with 6 other tables, and I'm doing a summation. That query plan will look and go, oh, you know what? What you're querying is already in one of the materialized views. I'm just going to return the results that way. And you're going to get the results in milliseconds compared to what could take quite a bit of time if it's an extremely large table with a complicated join on there. So materialized views are a great way to improve performance. And you can call these from Power BI on there. Uh, so they can be for that or ad hoc queries. The copy command I mentioned is very powerful. So you definitely want to test this out when you're looking to copy data from source systems on here. Think of this as an enhanced version of Polybase. And the parallelization on here makes it much faster because of some performance enhancements, as well as it's a lot easier to use because it's just simply a copy statement. With Polybase, you had a number of steps to get through in order to create an external table. We also have result set caching within Synapse. And it's a cache, and it's got some limitations, like it's 1 terabyte in size. And there's a few other things that would not cause data to be cached in there, like row level security. But outside of that, if you have end users who are submitting similar queries on there, it's going to go into the cache, and you're going to get millisecond response time when it pulls the data out of the cache. And you'll want to go in there, and by default it's off, so you want to turn it on. And once you do that, you'll immediately start seeing the huge performance benefits after the first time the query is run. Resource classes. So this is a way for Synapse to help prevent somebody submitting a query that's just overwhelming all the resources on there. So one way to do this is resource classes. You can say certain people or certain groups that have people within them using Azure Active Directory are going to get tagged with certain resource classes. And those resource classes are defined here, and they could either be static or dynamic. So if they're dynamic, you get more or less of resources depending on how you scale up and down on that, where static are fixed on there. But this allows, for example, you to put a data load query into the extra large resource class, so you're going to get up to 70% of the memory and get much faster performance. So you want to think through this of how you want to divide up classes, types by users and by functions and things like that. That's one way of doing it. A newer way of doing it that adds more functionality is through workload management. And this is divided into 3 areas: classification, importance, and isolation. And this will allow you to further define what people can do when they're on this Synapse workspace and avoid having complaints with end users complaining that they're not getting enough resources. And the way it does that at the first level is through a classifier. So this is a way to take a group of people and put them under a certain class. It could be one person, it could be Azure Active Directory has a number of people on there. And through that class, you can specify the importance, which we'll talk about next, and then assign them a workload group. Now, this group could be one of those predefined classes that I showed before, or it could be a new way of doing it, which I'll show you as one of the other options. The one thing you can specify is importance. So if I have a number of people that are running queries, they're queued up. If somebody comes along, in this case a national analyst, who has a higher importance level than a state analyst, he will sort of skip the line and will go ahead of those other ones in the queue. So a great way to have somebody's query run immediately as opposed to waiting if they have a higher importance need. We also have workload isolation. So this is the idea that I can create a resource group, think of it as, and specify the min and max that this group can use for CPU percentage, as well as for some other ones here like resource grants, as well as importance I can put on this too, and timeout seconds on here. So the idea, if we put all this together, is I can create a workload group called something like data loads, and any classifier can be assigned to this data load. So on the left here, I have the classifier of ETL login. That is going to use the workload group of the data loads, which specifies they can get 20 to 100%. I could have used the workload group on the right here of extra large, but this is a way to further define what they can use. And that classifier also has an importance of high. And the people inside that classifier are ETL login. So I can simply add a person to that ETL login group, or I can run some command using this member name, and they will get the data loads of 20 to 100% and high importance on that. So a great feature to think through and decide how you want to set up the resources and avoid a lot of the free-for-all that happens with other solutions where anybody can go and sort of overwhelm the resources. You can use whatever developer tools you wish, because also remember that it's using T-SQL to interface with a lot of things. So any product, third-party product that you want to use is likely going to work against the SQL pools or the on-demand pools. And in this case, I show, in addition to Synapse Analytics Studio here, you can use any of the other four ones. So if I jump out to my SSMS, you'll see here I connected to two different things. One was the on-demand pool, and then the other one was the traditional SQL pool. And those databases you saw when I was in Synapse Studio will show up here, and I can just easily just right-click this and go and select and use this tool instead if I didn't want to use Synapse Studio. I tend to find the DBAs continue to like using this tool, and especially for creating new tables and things like that. Whereas any end user or power user or somebody in IT who's a developer will use Synapse Studio. Azure Advisor recommendations. This is a cool feature that's still in the early stages, but the idea is this will monitor your databases and come back with recommendations on performance enhancements. So maybe it recognizes that your data skew, the distribution of the data among all those 60 distributions is not aligned equally, and will recommend, hey, try a different hash distribution key to get those more equal. Or it may say there's a lot of cache misses on there, so you may want to bump up your DWUs to get a bigger cache because there's limits on that based on your DWUs, or things like TempDB contention, or not using a good query plan and recommends that you update statistics. So all these will be automatically given to you on the Advisor Recommendation tab. There's also a predict statement that you can utilize in here. So you can use machine learning within Synapse to run the model. So maybe you create the model someplace else, and then you deploy this model to Synapse, and then within a SQL statement, I can use the predict statement that will go and execute that model. I pass in the parameters, and then it will output the result of that model, which you can then store in a database or such in there. So a great feature that adds the ability to execute models within Synapse Analytics. And then we have snapshots and restores supported within Synapse. And the idea is if I create a database, right away it's going to start backing up. And it does that at least every 8 hours. Usually it's 4 hours. And it'll take care of that for you so you don't have to go and create some job to go and do the backups on there. And the challenge is when you've got a data warehouse, usually it's a really large database on there, and backups can be a pain in the neck to to do as well as to restore. And especially if you're looking at disaster recovery options. Well, the great thing about this is it backs up that database and then copies that database from one Azure region to another. So if something goes wrong with the whole Azure region, you can simply log in to the portal, go to a region that's not been affected, that's up and running, and say, I want to restore a database, and it will look through your list of databases that were backed up, and it will say, oh, the database you want is not in region A because that had a problem with it, but there's a copy in region B, and so feel free to go and restore it. That restore will, because of using snapshot technology, will restore in under 20 minutes, no matter how many terabytes or petabytes size it is. And be aware of some of the RPOs that come into play when you're using this backup, which I find are almost always acceptable for customers. So this could be a way to have disaster recovery without having to sort of do dual loads of everything on here. So definitely check this feature out and understand that you can also create a backup on your own before a major event. So maybe I'm going to do a big data load. I can go and trigger a snapshot and it'll do the backup. And then I can wait till that's done and then go ahead and do that massive loading on there. And you can have up to 42 of these user-defined restore points on there. So a lot of data could be backed up. And then lastly, I wanted to point out how using Synapse in combination with Power BI can give you tremendous performance and boosts on there. If we look at the bottom left here, Synapse has features I talked about, like results to cache. It puts some data in memory, and it's as well as in zone adaptive cache. You have the materialized views. You have high performance I/O. Using those in combinations with Power BI, features such as importing everything into in-memory or using dual tables, the composite mode, and using direct query can give you millisecond response time. For example, I can use Power BI queries that have imported some data, and using the dual mode, I can say, I want to use direct query in some cases. So if it's in memory, great, millisecond response time. If it's direct query, that could take longer because it's got to go out to Synapse. But if it goes out to Synapse and it's using something that's sorting in results set cache or in materialized views, you're going to get that millisecond response time on there. So different layers for optimizing your performance. So you want to be aware of all these layers when designing a solution. And I always tell customers, be aware of the smell test. If it doesn't seem right that it's taking too long, there's probably a feature that you can do to give you the enhanced performance. And so reach out to Microsoft for help or try to dig a little bit more into some of these features to see if you can use them to get the performance you need. Great. So that's my presentation. I have a blog that goes into detail on a lot of the topics I talked about, so you can get more detail, and that'll help you in understanding some of these features better. And then feel free to reach out to me. My email is right here. If you have further questions, shoot me over an email. I'm happy to answer. And I hope you enjoyed the session today, and I hope you're enjoying virtual SQL Bits. Thanks so much.